Hello, everyone. Thank you for coming. My name is Julian Edwards, a DBA student at the California Intercontinental University, and today we're going to be discussing conducting a correlational test. Our agenda for today will be first to define correlation. We will discuss the types of correlations, discuss the significant correlations using the GRC 605 dataset that was given, followed by our main takeaways from the presentation before our conclusion. Now, correlation can be defined as a statistical technique that describes the degree of relationship between two variables. Now, your correlation coefficient, usually prescribed as R, is also referred to as the Pearson product moment correlation coefficient, and this is represented as a single number between -1 and +1. Your correlations may be either positive, where your coefficient is greater than zero, negative, where it is less than zero, or there can be no correlation where R is equal to zero. Your correlation can be represented graphically using your scatter plots as shown in the photo on the slide. With a positive correlation, you would see a general upward slope on your graph where an increase in x would result in an increase in y. For your negative correlation, you would have an increase in one variable associated with a decrease in another variable. When there is no correlation, there is no strict pattern as to whether a variable is increasing or decreasing as the other increases or decreases. And in this instance, as we said, your coefficient would be equal to zero. Now we're going to begin looking at the significant correlations that were found using the data set. The first significant relationship was found between income and savings. Our test was conducted where our null hypothesis was stated that there is no correlation between an individual's income and their savings. Our alternative hypothesis therefore stated that there is a correlation between an individual's income and their savings. A correlation coefficient and p-values were calculated using the PSPP software, assuming an alpha level of 0.05, and a significant relationship emerged where R was found to be 0.91, with p being 0.000. In this instance, we would reject our null hypothesis and conclude that there was a correlation between the two uh, variables, income and savings. And from our scatter plot, we can have an idea that it's a linear positive correlation whereby increase in savings is usually associated with a higher income. Our next correlation we stated our null hypothesis that there was no correlation between an individual's income and their stock value. With our alternative hypothesis again being that there was a correlation between the two. From our statistical tests ran using PSPP, our correlation coefficient was found to be 0.19, and our p-value 0.018. And in this instance, again, we would have to reject our null hypothesis and conclude that there was a correlation between an individual's income and their stock value. Now, using our scatter plot, our relationship or association is not as strong as our previous examples, not as linear. However, there is what we call the line of best fit that would show the general increase in our slope on our graph, where an increase in stock value would be associated with a higher income. Our next correlation was the income versus the amount of money or cash carried around in a person's wallet, where null hypothesis stated that there was no correlation between the two. Alternative hypothesis therefore stated that there was a correlation between an individual's income and the cash carried in their wallet. We ran a statistical test again using PSPP with our correlation coefficient being 1.00, with a p-value of 0.000, and that is what we describe as a perfect correlation, a perfectly positive correlation as dictated, as outlined on our scatter plot, which is essentially a straight line where the more money that's carried in one's wallet is usually associated with a higher income. Our next correlation, there've been savings versus stock, where our test was conducted with a null hypothesis stating that there is no correlation between an individual's savings and their stock value. Alternatively, our alternative hypothesis would then state that there is a correlation between an individual's savings and their stock value. Statistical tests again were ran, where we rejected our null hypothesis because we found a correlation coefficient of 0.28 with a p-value of 0.000, which again signifies a positive relationship, whereby a higher stock value is usually would be associated with more savings. Or other correlation test that was run would be savings versus the amount of money an individual would carry in their wallet. A null hypothesis would state that there is no correlation between an individual's savings and the amount of cash carried around in their wallet. But the alternative hypothesis stating that there is a correlation between an individual's savings and the amount of cash carried around in their wallet. From our statistical tests, we found that our correlation coefficient was 0.91 with a p-value of 0.000, again rejecting our null hypothesis and concluding that there was a correlation between an individual's savings and the amount of cash carried around in their wallet. Our scatter plot highlights a very linear presentation where as the amount of money that's carried in the wallet increases, so too does the savings. That we would describe that as a positive correlation. Our final correlation test that was run, we stated our null hypothesis that there was no correlation between an individual's stock value and the amount of cash carried in their wallet. Our alternative hypothesis was therefore that there is a correlation between an individual's stock value and the amount of cash carried in their wallet. Our statistical test then returned a correlation coefficient of 0.19 with a p-value of 0.017, again rejecting our null hypothesis, concluding that there was a correlation between an individual's stock value and the amount of cash carried in their wallet. Our our correlation coefficient is greater than 0, and so we conclude that it is a positive relationship where the more money that's carried in one's wallet is usually associated with a higher stock value. Our main takeaways from this presentation are that the correlational test determines the presence of a relationship between two variables. It also describes the direction and strength of this relationship based on our Pearson coefficient, or R value, that is always between -1 and 1. If ever our correlation coefficient is less than 0, that's considered a negative correlation. If it's greater than 0, then it's a positive correlation. If our correlation coefficient is 0, that would dictate that there is no correlation between the two variables being studied. In addition to the Pearson coefficient, these relationships or these correlations can also be presented graphically with the use of scatter plots. Thank you so much for your time. Should you have any questions or comments, please feel free to ask.